So we are starting with circular motion. If we talk about circular motion, and if we consider in our daily life, so we can see that many things move in a circle. Like examples, we can consider wheels of a car or bicycle, wheels of a car or a bicycle, Earth orbiting around the sun, Earth orbiting around the sun, hands of a clock, spinning DVD, drum of a washing machine. All these are examples of circular motion, and there are many more. Now, sometimes there will not be a complete circle, but path will be a part of a circle. Consider example, car is moving on a straight road, and then there is a sharp bend in the road. So when car will move along this track, so that will also be an example of circular motion. About linear motion, we have discussed in AS level. Circular motion we will be discussing now. If I consider example of hands of a clock only, hands of a clock, if I consider second hand of a clock. So this is initial position. I will consider this initial position that is at 12. Now, if I talk about the complete revolution, let's it the second hand. Here I am considering second hand. Second hand starting from this position and it covers one complete revolution means again it reached this position, right? So when it has covered complete revolution, then it has completed an angle of 360 degree, right? And to cover this 360 degree second, time taken is 60 seconds, right? So this means 6 degree is covered in 1 second. 6 degree in 1 second. So hand is moving by 6 degree in 1 second. So if you know the angle theta through which the hand has moved from the vertical position, we can predict the position of the hand. Like if I say it has moved 60 degree. So if it has moved 60 degree, this means it has moved 60 degree in 10 seconds. So I can predict the position of the hand. In the same way, we can describe the position of any object as it moves around a circle simply by stating the angle theta of the arc through which it has moved, right? So this angle theta through which the object has moved is known as angular displacement. So there is a new term, angular displacement. And how we define this angular displacement? It is defined as the angle theta through which the object has moved. Like if we consider linear motion or if we consider object moving in a straight line, so its position is defined by displacement, right? Or the distance it has traveled from the starting point. So corresponding quantity for circular motion is angular displacement or the theta. Theta means the arc through which the object has moved from its starting position. Let's say initially the object is at this position A, right? And after a time t, object reach position B. So when object reach from A to B, it has covered this angle theta, right? In certain time t, let's say. So this theta is known as angular displacement, right? But when we are dealing with the circular motion, right, or circle, so we should consider angles in, we should measure angle in radians, right, rather than in degrees. So how to measure in radian? Let's say when object has moved from A to B, the length of the arc covered is S and the radius of the circular path is R, right? So angle in radians is defined as length of arc divided by radius. Let's say this length of arc is S. So sorry, angle is theta. So theta will be equal to length is S divided by R. So theta is equal to S by R is relation between angle, length of the arc and radius. Now, here only if I consider a situation, if the length of the arc is doubled, right? Length of the arc is doubled or object moves twice far around a circle and the radius of the circle is also double. In that case, what will be new theta? So theta will be 2s by 2r. Again, theta is equal to s by r. Means theta will remain unaltered. Now, if we consider one complete revolution when particle is moving, uh, let's say particles or object starting from point A and after covering one complete revolution, particle reached again point A, right? So in this case, if I have to write expression for theta, how can I write? So theta is equal when one complete revolution is made. So distance covered along the circular path is given by the circumference, that is 2 pi r divided by r. So r and r get cancelled out, so is equal to 2 pi. And we know that when one complete revolution is there, so there is 360 degree. And here we have defined theta as 2 pi. So this is relationship between angle in degrees and radians, that is 360 degrees equal to 2 pi. If 360 degree equal 2 pi, what does that mean? This means that 1 degree is equal 2 pi upon 360 radians. That is 1 degree is equal pi upon 180 radians, right? And if I have to write for 1 radian, so 1 radian is equal 360 degree by 2 pi, right? Or 180 by pi degree, right? So using this relationship, we can convert any degrees into radians or any radians into degree. Let's say I have to write for 180 degree, right? So 180 degree will be equal to, since 1 degree is pi by 180 radians, so 180 degree will be pi by 180 into 180. So this is equal to pi radians, right? One more example, if I have to write for 45 degree, so it will be in 1 degree there are pi by 180 radians. So in 45 degree there will be pi by 180 into 45. So this will be equal to pi upon 4 radians. Right. Similarly, from radian to degrees, if we have to convert, let's say if I give you pi by 6 radians and I ask you to convert it into degrees. So 1 radian is 180 degree by pi. Pi by 6 radians will be 180 by pi multiply by pi by 6. Pi and pi cancel out is equal 30 degree. If I ask you to convert pi by 2 radians, so pi by 2 multiply by 180 by pi and pi will cancel out 90 degree. This means कि using these two relations, you can convert any degrees to pi and any pi to radians. Be careful when you are converting from degrees to radians, right? Here, what you have to do is you have to substitute value of pi also. That is, if you are doing it on your scientific calculator, there is pi button on your calculator. You can press that button. Otherwise, you can substitute 22 by 7 for pi or 3.14. Now, how can we define 1 radian if I ask you to define 1 radian? Now, if you have to define 1 radian, so let's say object starting from point A reached point B and circular path has radius r. if the length of the arc is equal to radius of the circular path, let's say length of the arc is also r, then angle will be 1 radian, right? Because we know that theta is equal to length of arc by radius. Length of arc is r, radius is r by r, 1 radian, right? So 1 radian is defined as the angle. 1 radian is defined as the angle subtended at the center subtended at the center of a circle by an arc of length by an arc of length equal to the radius of the circle. Radius of the circle, right? So 1 radian is equal, if we write value, 1 radian is equal 360 degree by 2 pi, right? If you will put the value of pi, so you will get approximately 57.3 degrees. So this is the value of 1 radian.